Hello, and today we're going to be looking at the ambiguous case of the sine rule. So what the sine rule does is it assumes that we make a triangle that looks something like this and not something like this. And what I mean by that is that you can have two lines connecting to this bolded dotted line here of the same length, and it will assume that regardless of the values that it is the bigger triangle. I encourage you at home to get a protractor and get a ruler and actually do this yourself, because it will make a whole lot more sense if you do this perfectly, and you have a better understanding if you do a diagram. First thing that I want to do is I want to find the shortest distance between this line here and this line here where I can make a triangle. So I want the shortest distance from here to there. So how are we going to find this special midpoint? Well, we're going to have to do a right angle on this dotted line and draw it out like this. So what we end up with is this nifty right angle triangle, and we can actually use this right angle triangle as a base for this ambiguous case here. So let's assume that that there is 90 degrees off this dotted line here. If that were the case, how long is this line? What is the length of this shortest line? Well, we can use trigonometry. We know that this is 30, this is 60. We can use trigonometry to find out this length here. So what is this distance here? Well, let's work it out. So that is equal to x. We can use sine, because we know that this is a right angle, to work out what this x is. So sine 30 equals opposite x divided by our hypotenuse 6. 6 lots of sine 30. Remembering back to the first episodes of advanced trigonometry, exact values, sine 30 is just a half. A half of 6 is 3. So 3 equals x. So what we have here is we've calculated a minimum value. And this minimum value is going to be a constraint for the ambiguous case. So let's get rid of this. And now let's say I want to draw a line from this point here to a point on this dotted line here in such a way that the length from here to the dotted line is 4 centimeters. Let's try and do that. Let's find a point where we can find 4 centimeters. That looks like 4 centimeters here. Okay, can we find another place for this line? Well, of course we can. We can do this. That's 3 centimeters. Let's see if we can find 4. It's not perfectly accurate because this is on a computer screen, but if you did this at home, which I again encourage you to do, you can get this all nice and perfect. So now we have a problem, because these two are both 4, and you can see that the sine rule now breaks down, because what if I want to work out what this is here? Let's say that's theta. Or what if this was theta down here? How do I work this out? Logic would tell you, use the sine rule. However, the sine rule assumes that this is true and not this. You have this problem with the sine rule, is that it will always assume that this here is the angle that you're talking about, this theta up here. If that's not what we're looking for, we need to be able to identify when the ambiguous case actually applies and how to deal with it. Now let's start by doing some labeling. I'm going to label this A, this is going to be point B, and I'm going to label this C1 and C2. So I want to find what C2 is equal to, but I don't know what C2 actually is. So let's use the sine rules. Sine of C1 divided by 6 sine 30 over 4. Even if we put C2 here and try and work out C2 in our equation, it will still give us C1. Let's work out what C1 is. We already worked out this is 3 up here. 3 over 4. C1 is the inverse sine of 3 over 4. And that comes out to 48.59 degrees. And that's C1. If we look at our triangle here, this is not an acute angle. This is nowhere near 48.59 degrees. Like I said before, we found C1, which is not what we wanted. We wanted C2. So how do we use this to work out what that is? What type of triangle do we have here? We have an isosceles triangle. It means that these two angles here are the same. So if they're the same, this is 48.59 degrees, and that here is also 48.59 degrees. So now we have a straight line, and we have a line coming out like this, and we know that this is 48.59 degrees, and we were trying to find out what this is here. But if this is straight, then we know that this must add up to 180 degrees, so we can subtract 48.59 and work out what this large angle here is. So we can find out what C2 actually is. So C2 equals 131.41 degrees. So that's the ambiguous case. We can't just assume that the ambiguous case works with any triangle. It doesn't. There's certain things that you can and cannot do, and you can use that to work out whether the ambiguous case actually applies. So the first thing is it has to be bigger than this x value over here, which we worked out was 3. So for this particular triangle here, the side length had to be greater than 3. Why? Well, if it was anything less than 3, it couldn't make a triangle. It just simply couldn't reach this line here, and we couldn't make a triangle. We have a minimum value. What about a maximum? Well, the maximum has to be 6. So if we had anything greater than 6, we can't get a point from B and join it up with this line here. What we end up with is that this line comes out over here, and that will be greater than 6. So that's all the time that I have for today for the ambiguous case. If you have any questions, feel free to contact me on social media or in the comment section below, and I will see you in the next video.